Now moving to the next property of ionic compound, and that is the electrical conductivity. So the third property which we shall be dealing is the electrical conductivity. Now student, as already we know that in ionic compounds we have the presence of cation and the anion. Like if we discuss about NaCl, we find that on dissociation NaCl gives Na positive and Cl negative. Means due to the presence of charge, these ions will lead to electrical conductivity. Hence, in case of ionic compounds, there is presence of positively charged cation, like in NaCl we have got Na positive, and the negatively charged anion, that is chloride ion. These ions or charged particles on migration, on mobility, will lead to electrical conductivity. Now, in this section we shall be observing that how we can compare the electrical conductivity of different ionic compounds. So the very first point we have to observe that ionic compounds can be present either in a particular solvent, that is in a medium, or they can be alone. So let us take the first case, case 1, that is when ionic compound is not present in a solvent, that is in absence of medium or in gaseous or molten phase. So basically here we are considering a case where we are not dissolving an ionic compound within a medium, that is in a solvent, means we are considering its gaseous or the molten phase. Now remember, in case of the gaseous or the molten phase, the very first point to be observed is electrical conductivity will be inversely proportional to the polarization. Means greater is the polarization, smaller will be the electrical conductivity. Now let us consider an example. Let us take LiCl and NaCl. Now in LiCl and NaCl we are finding that the anions are common but the cations are different. Here in LiCl, Li will have smaller size as compared to Na. And student, already we have discussed in the Fazan's rule that smaller is the charge of the cation, more is the extent of polarization, and hence less will be the electrical conductivity. So in LiCl, what we observe, lithium due to smaller size will lead to greater extent of polarization as compared to sodium in NaCl. So due to greater polarization of LiCl, its electrical conductivity will be smaller. So once we compare, the electrical conductivity order will be LiCl will have smaller electrical conductivity as compared to NaCl. Again, what we are finding that in case of LiCl, the covalent character or the polarization extent will be greater. So due to greater polarization in LiCl than NaCl, NaCl will possess greater electrical conductivity.